Hey there, YouTube types, coming at you a little earlier today. We'll be doing two streams, I suspect, God willing. This one is the meteorology one. We'll keep that largely separate from the space weather video for today. So we actually got a little bit of a dud here where we're located in Lehigh Valley, Pennsylvania, and that means that we didn't get the crazy snow that was in the forecast. Like there were some forecasts for as much as 12 inches and so on, and we just ain't got it. I mean, I think we got maybe 4 inches here, but keep in mind we could have locally very deep snow conditions because it was like a blizzard last night. You know, there was heavy winds, and the Lehigh Valley is full of low-lying valley areas, and as a result of that, oftentimes we get huge, very dense bands of moisture that get funneled into those valleys. So, you know, sometimes that'll steal all the moisture from that area. So you can get this valley has 12 inches and the valley right next to it has 3 inches or something like that. And that's pretty much what we see now. So while the snow showers will continue throughout the day, it's going to look more and more like just a fade out. And yeah, so no more significant accumulation will happen with this particular system, but there's actually a second series of snow coming through, so we'll show some forecasts about that. It should be helpful for all of you Boston to DC corridor types. And we're gonna do it guerrilla style, the same way we typically do for the daily space weather streams. Let me change the lighting around here a little bit to make the screen a little bit easier to view for people like you. And we'll show you some weather data here. Because the very strong low that formed off the coast of Maryland, it's now moving out to sea. I believe it's moving north, but we'll show you the data here so that you can have effective concepts of what the weather's doing. Of course, everybody ought to know how to forecast your own weather. Weather forecasting isn't that hard if you understand the physics of the atmosphere and so forth. So we hope you're able to do so. That is, forecast your own weather. You've got more than enough stuff to be able to do that. So here's a view of the U.S. Doppler radar map, and this coastal low here, it is absolutely just pumping moisture into New England right now. So Providence is getting absolutely plastered. I mean, look at those heavy bands of Atlantic Ocean moisture there being rotated around that low as cold air kind of moves its way in from Canada once again as well, creating the sort of the perfect mix there of incoming moisture and cold air that is sort of the catalyst there. So I saw the temperature was down as low as about 960 millibars there. That is quite a strong low indeed. And if you look at it on windy.com satellite map, oh, we're at Antarctica because reasons. I believe it's because that's our officially designated location. Because we cold up in here. We cold up in here. So here's that low that's been bringing all that crazy snow, blizzard conditions. You could say it's a snow-a-cane or a bomb cyclone. It's a classic nor'easter. It formed right around here, right near just off the coast of the Del Mar Peninsula. And now it's kind of loitering, okay? So we do have some thunder snow there falling in the western Atlantic as well. You can see some lightning popping up there on the map. There's the radar image. So yeah, we're only expecting another like dusting to an inch throughout the day today, but the snow will continue probably until around noontime. So for all the Lehigh Valley viewers, yeah, less than 1 more inch is likely throughout the day today. So don't expect anything big. The high is going to be about 36 degrees. Tomorrow, a high only near 30. So that cold air is going to move in and it's going to solidify some of this stuff because we're going to get some melt. So you're going to have a crusty snow top once again. Here's the water vapor map. Let's actually just refresh that so it's the latest. So there's your water vapor map. You can see that strong low there is moving to the northeast, and it is entrained by dry massive air here. So the eastern and southern portion of it are quite dry, so huge pressure gradients forming here on the northern portion of that low. And you can see it's both pulling air down here from Canada. You can see a little bit of that flow. Let me animate the whole map here. You'll see, since that low is so strong, it's going to be pulling air down, and it's, well, there, I mean, you can see what's happening there. That's a pretty good map. Let's show the cloud tops here by looking at the visible satellite, because we like to keep an eye on it. And by the way, in the description below this very video, you can find our merch shop. And when I say keep an eye on it, well, the pun is intentional. So it's a very high resolution image of the closest star there from SDO. That's the house favorite 171 angstroms wavelength. It's a custom edit from when the sun was quite active there, right near solar maximum. So if you want a high res image of the closest star there's a bunch of merch you can get it on. And it does have the YouTube channel on there as well. So please press that share button. Tell your friends and foes about us, since YouTube, frankly, does a pathetic job of promoting this channel, which plays advertisements and even pays for advertisements. So you would think there'd be incentive, but it's whatever. All right, so I'm going to animate this image here. And it's still too dark over the Atlantic to really get a good shot of that. Let's take a look at the shortwave radiation map, just for the fun of it. There's a shortwave radiation map. And shortwave radiation map is cool because it shows you clouds at nighttime. Water vapor emits a lot of radiation, folks. That is infrared radiation, what we're talking about here. That is 3.9 nanometers. Great view of that low. And you can use the shortwave radiation map to show you where the aurora are likely to be visible. If there's a strong aurora night, if you're trying to see the aurora borealis or australis, if you have access to a shortwave radiation map, it's going to show you if there's likely to be cloud cover out there. Of course, you could always go out and see if you see stars. That works too. But if you refuse to look outside, yeah, that's one way you can figure out what's going on. The shortwave radiation map. So there's the full disk view as the sun slowly rises over the Atlantic. So that's what's going on with the system. I mean, New England is going to continue to get plastered here for an extended period of time. And let's actually zoom. We're going to zoom in on this moisture up here around Massachusetts and so on. And you can see that loitering low there is just pumping moisture out of the Atlantic. And when it hits that cold air, it becomes precipitation rapidly. And of course, dry air is more massive as well. So you have a huge pressure gradient that's forming right here. In fact, let's show the pressure map here. We'll go to nullschool.net. But first, the wave map. I mean, the highest seas in the world, you might think that they're off the coast of the Delmarva Peninsula there, but really, they're actually out here in the North Atlantic. We've got 38-foot waves out there, but that's what's going on as far as this system that's affected the Boston, D.C. corridor. So there are the winds. You can see quite strong winds there. We are seeing winds up to about 70 plus miles an hour. So basically hurricane gale plus force winds there. Did kick up on the southern end of that system. And you can see the way all the air is just drawing toward it. This low is so strong that the jet stream does play a role in this one. Anyway, there are the jet streams. And let's take a look at the pressure situation, because the pressure has come up a little bit, I think, here. But here's the pressure at sea level, known as the MSLP, the mean sea level pressure. And this low is now down to about 969 hectopascals. So that's still quite a strong low. 967 hectopascals. So that's practically hurricane level, folks. Does it have hurricane force winds? Not really. But keep in mind, cold air is more massive than warm air, so it doesn't quite move as fast due to its higher mass. So, but there's the pressure situation. As you can see, that is quite a highly concentrated low pressure there. And it's still just off the coast of South Jersey there. And it is moving to the northeast. So this is going to continue to loiter, though. Yeah, as you can see from those animations we showed earlier, it's going to be moving very slowly. If I move this ahead 1 hour, this is the forecast for how it's expected to move. It's just going to slowly make its way up the coast there, moving up to Cape Cod and so on. That's 1600 local time. So by 4 p.m., it's going to be off the coast of Cape Cod. So that's what's going on. Yeah, it's pretty significant snow hit last night. I do see your comments there. Thanks for leaving comments. Squirrel Sniper 138, greetings, beautiful souls from across the pond, but under the same skies. Yeah, thanks for dropping a comment. And thanks for dropping a comment, All the Sun 7114. So we'll end this stream here. When we do the space weather stream, I'll show some forecasts. I just wanted to do a short stream about how, well, this thing has kind of been a dud, at least for where we're located. But again, like I said earlier, there are some valleys that probably have very high amounts. We have some varied terrain around our residence here, and I checked it out this morning. So there are some spots that are almost bare where you can still see the grass, as we were down to about 15% snow coverage by the time the storm started yesterday afternoon. But there are parts where there's grass exposed still, and then there are parts adjacent to that, like the wayward side of a hill, where a bunch of snow got deposited. So this makes it really hard to check snow totals, but we're going to see a huge variation of snow totals in the Lehigh Valley area. Because again, valleys, you have a process called orographic lifting, and that means, you know, when an air mass approaches a hill, the hill forces the air mass up, and that changes the temperature and pressure characteristics and so on. And, you know, and also just the blowing of the snow itself, just the physical blowing of the snow, you know, it's going to get deposited on the wayward side of a hill for the most part and leave the top of the hill bare, but then the other side of the hill, a huge snowdrift. So this is what blizzard conditions do. I have another comment here. Those green-yellow gradients on the map from over here near Brighton, do you see those as purely weather patterns, or are we looking at a specific signal reconstruction of the atmospheric layers? I don't know what that means, a specific signal reconstruction of the atmospheric layers, but that's definitely not a thing. So I see purely weather patterns. Weather patterns are governed by basic physics. So you say you're across the pond. Where you're located there, Squirrel Sniper? Yeah, I guess you're a good marksman because squirrels are small targets. But in any case, yeah, like here's your pressure map. Another good one to look at if you're confused about the weather patterns would be total cloud water. Total cloud water is going to show you the precipitable amount of water there. And so, yeah, I mean, you've got this strong low way up here in the northern Atlantic, and that's definitely affecting your weather. I mean, look at the pressure map. Now it's going to be drawing your weather in some funky directions there. And if you look at the jet stream, you've got, what happened? If you look at the jet stream, you've got warm air that's way up here. Plus, you've got the Gulf Stream, which is warming up places like Ireland and Iceland and Norway. So that's another feature that's super important for your weather. If you look at sea surface temperature, okay. data not available for this. Oh, because we're not looking at now anymore. Okay, there's the now. There's the current data. And let's look at let's go back to what I was just showing you there. So there's the jet stream at the current situation. And let's see, here's your pressure map. And then, of course, it is important to understand the jet stream. What the fuck is this? Oh, I got to go to wind. There we go. So there's a surface wind situation. And here is the jet stream for now. And the jet stream is super important. It's going to show you if the air is going to be, warmer or cooler than usual. But yeah, as far as specific signal reconstruction of the atmospheric layers, that's a bunch of buzzwords that are thrown together that don't make any sense. They're signal reconstruction of the atmospheric layer. Signal reconstruction of the atmospheric layers, that's not a thing. So anyway, if you have any other weather questions, drop them in the comments. Are you observing any tropospheric scatter in these coordinates that might indicate a phase shift in the atmospheric signal propagation? Yeah, there's tropospheric scatter all the time because the troposphere has a lot of matter in it. And so all of that matter causes scatter. But it depends on what you're talking about scattering. Are you talking about the scattering of radio signals, of light, of infrared radiation, ultraviolet radiation? What are you talking about? And what atmospheric signal propagation are you talking about? Are you talking about the propagation of atmospheric signals for weather data? Are you talking about radio signals, electromagnetic radiation? Are you talking about what signals? What are you talking about? Sounds like a bunch of buzzwords. Anyway, we'll have to end this stream because we're going to be doing another one probably around, I don't know, like 9 a.m. or something like that, because space weather will be interesting because we got all the way down to 0 sunspots. We'll let you know later in the day if we're still at 0 sunspots. And but yesterday, sunspot number was 0. So if you are spooked of 0 sunspots, you're probably still in your bunker. So, but maybe your bunker is not inside of a Faraday cage and you're able to view the videos. So we hope you are. And if so, definitely tune in probably again around about 9 a.m. today. We'll do another stream to cover space weather as we're wont to do most days, at least weekdays, and even on some weekend days. So, but this is where we'll close things out. Let me just show one more weather map, and then we'll call it a stream. Let's just show the full U.S. water vapor map since we haven't shown that yet today. As an atmospheric river makes it ashore once again here at Oregon. Shout out to our viewers from Oregon. Oh, any 3i Atlas talk? Yeah, I'll talk about 3i Atlas, and thanks for leaving a comment. Jamie Turd Pencil NYC. Yeah, I'll talk about 3i Atlas. So 3i Atlas is a comet, not an alien spacecraft, not a probe, not alien technology. It did start to do some funky outgassing things, and that would be consistent with a really old comet that has built candy coating on the outside of it because of cosmic rays striking it for probably billions of years. I would say at least hundreds of millions of years at the minimum. So yeah, I'll talk about 3i Atlas, a comet. It's doing everything that we would expect an interstellar comet to do and absolutely nothing that we'd be expecting a spacecraft to do. So there's that. And I can't stand the nonsensical talk about how, 3i Atlas, it must be a spaceship, because it looks exactly like a comet. So there's that. Anyway, it's time to close this out. We'll see you soon here at the Smash News Network, the Busted Name of News. I've been your host, Dan, a.k.a. Smash on Mash, signing off. Don't forget to press the share button. If you're new to the channel, press subscribe. Otherwise, you won't see the world's most comprehensive daily space weather video. directly in your YouTube feed. So thanks to everybody who's left comments. Don't forget to tune in a couple of hours here for another stream. This one will be about space weather. And until next time, may that solar wind and those blizzard winds be at your back.